Hi guys, welcome to this next video. Together with me today is a very special guest, Jared Cowart from NVIDIA. He's a technical product manager, and today we're going to explain something around the history of GPUs. So, Jared, could you explain the viewer what how NVIDIA approached the whole graphical acceleration market before vGPU was born?
Yeah, it's a great question. So as we were talking kind of ahead of time before this, we thought it'd be useful to talk about before NVIDIA GPU. What was there? How did people work within a hypervisor and some of the things? Obviously, we know there's a ton of history around graphics that we could do a whole entire series on around where they came from, where they began.
Probably gonna do.
We probably will. This is really focusing predominantly around our VMware, Citrix, Hyper-V, virtual desktop type of solutions, and historically where those solutions were. So before there was NVIDIA Grid, and this was about 7-8 years ago is when NVIDIA Grid was launched, but before that, what were the solutions that we had? Or if you choose not to use NVIDIA Grid, what do you use nowadays? So the way that I want to kind of explain this is that we really focused our users around, or our use cases around user types. So as we know within desktop virtualization, we have kind of our task users. And in our task users here, the types of solutions that have been available prior to vGPU were typically a soft graphic solution. So, kind of draw a bubble here.
Basically like a GPU emulator towards software.
Exactly. It was a kind of a driver that your VMware or your Microsoft wrote. And they wrote this driver. It had very limited APIs, so it could do basic, DirectX, things of this nature. But it was the CPU that had to do that heavy lifting. So I kind of call this a soft GPU. Right. So this was a soft GPU, and pretty limited in what it could do, but it kind of got us there. So even today, if you were to use a solution with VMware or Microsoft, right out of the gate here, this is going to be what you're going to get. Yeah. So if you're saying, I think I need graphics, this is what you're getting now. Right. Is that thing. We then dealt with our knowledge users as well. So this is a little bit higher up user, so kind of knowledge users here. And in this knowledge user use case, VMware and both Microsoft had a solution here, and they still have these solutions as well. They're not heavily leveraged, but this solution, I would kind of call a little bit higher up on the thing here. And this solution here in the VMware world is VSGA. Right. And in Microsoft's world, it is Remote FX. Right. And so what this guy does is it is a solution to where the hypervisor actually contains the driver. So in an NVIDIA use case, we actually install the driver into the hypervisor, and now the hypervisor has an awesome graphics driver in it. Right. So this is basically the first emulation that uses hardware to accelerate. It does. So this is actually hardware, so it's really important here. Yeah. This is hardware accelerated. Right. But it's limited because if we look at this from a hypervisor perspective, and maybe we can even draw this, we've got our GPU here, right? Yeah. So this is our GPU, and above this GPU we've got our hypervisor. And in the situation where we've got our hypervisor here, we actually install the NVIDIA driver here. So this has got our driver. And then in the hypervisor, of course, we have hopefully hundreds of virtual machines. So this would be our VM here that is running. Yeah. In this virtual machine here that's running, we actually put in a Microsoft. So this would be a Microsoft driver or a VMware driver. Yeah. That's installed here. So what has to happen is this guy is kind of in an API intercept is the nomenclature for this. Right. So this guy looks for OpenGL, DirectX calls that it can function with, and then it says, hey, I see that, go ahead and pass it to this driver. So it passes it to this driver, and then this driver goes down to the hardware, and it handles that on behalf of that. So we've got some latency and things that are implemented here. But in effect, this is the driver that's actually processing everything. And this is not an NVIDIA driver. This is a Microsoft Enter or whatever. And I think that the NVIDIA and all the different graphics companies probably know how to write the drivers best.
Yeah.
So this is a kind of a third party writing it. So if we were to write a list of cons over here, this is going to be limited API capabilities, overhead, latency.
So it does have like DirectX support and OpenGL support, but it's limited towards
so it's
certain versions, right?
Yeah, it's like DirectX 9-ish, OpenGL
9C if I'm not mistaken.
9C, I believe, and then like an OpenGL like early editions, like eight years ago, kind of OpenGL. So limited capabilities here. Yeah. So this was a solution that if you're familiar with VMware, you drop down the box, you see that hardware acceleration. This is that solution that you would see there. But definitely not on par with like having a full GPU like in your physical workstation. Right. So we got to task our knowledge users. Then we got over into, we'll kind of break this down into power performance users. So when we got into power users or performance, our high-end designers. So we got into these guys. We now are up into this realm. And things that we needed for this user were things like CUDA. Yeah. We might have also needed things, we're dealing with like designing applications. So, your AutoCAD or Compute, CATIA, SolidWorks, higher end use cases. We needed a solution that enabled us to have full access to the GPU, and this was pass-through. So, pass-through or... So
you're completely passing through one card towards the VM.
Yeah, and I'll show you. PCI pass-through. PCI pass-through. The PCI device actually goes into it. And actually, the PCI device disappears from the hypervisor. You don't even see it anymore. It's now a part of that machine. So in a pass-through scenario, Microsoft called this DDA, Direct Device Assignment. VMware called this VDGA. And then, in a Citrix world with Zen Server, they have this as pass-through, which is what they call it. So kind of how they all list this out. So super high performant solution because you have the whole GPU to yourself. There's no like multi-users on it. Unlike this guy, you could do some multiple users. But in this solution, we now have the ability to do, one user with unbelievable performance. But kind of the negative to this one is one-to-one. So we've got one GPU to one user, and oftentimes if you look at servers nowadays, we can only get so many in.
Because the PCI device is linked. Stuff like vMotion isn't. You're not able to vMotion here.
No motion here. No suspend resume capabilities here. This is locked to a host. Definitely takes some more planning. And then as we get into this guy, we do have motion. We do have motion in these types of solutions, but this guy we did not. Right. So. This is kind of historically what we've had before vGPU, and what we really needed, and the reasons why NVIDIA invested with the vGPU solution is to essentially get the benefits of this solution and the density and scalability of this. So this gives us that. So I think next maybe we'll talk a little bit about how that works, but hopefully this gives people an understanding a little bit about the future or the past and why we moved to where we were today.
Cool. Okay. Awesome. Well, thanks guys for watching, and enjoy the next video about vGPU.